Hi everyone, myself Dr. P. Soumya, working as an assistant professor in the Department of Chemistry, Institute of Aeronautical Engineering College. In this session, I am going to cover the topic solid waste, municipal solid waste and its management. In this session, I am going to cover the topics introduction to the solid waste, classification of solid waste, engineered systems for solid waste management, and methods for the solid waste management, management of solid waste. So, what is the introduction about waste? So, what is waste? This is the waste. So, this is depending on the physical state. This is classified into three types: liquid waste, gaseous waste, solid waste. So, waste it is classified on their physical state. So, that is a classification. This is having three classifications: liquid state, liquid waste, gaseous waste and solid waste. So here solid waste. What is solid waste? Solid waste, it is the unwanted or useless solid materials generated from combined residential, industrial, commercial activities in a given area. Solid waste, it is a unwanted or useless solid materials. These are generated from combined residential, industrial as well as commercial activities in a given area. So this is called as a solid waste. So, what are the sources of solid waste? So solid waste sources are solid domestic garbage, solid waste material, so which is from industries, and solid agriculture waste, plastic, glass, metals, electronic waste, etc. These also come under solid waste. So here medical waste also solid waste in medical waste, and construction waste, sewage, sludge waste. So these are the sources of solid waste. So what is solid waste management? Solid waste management, it is the process of collection, transportation and disposal of solid waste in a systemic and economic hygienic manner. So solid waste management, it is a process of collection, transportation and also disposal of solid waste in a systemic, economic and hygienic manner. So and also another definition, that is solid waste management, it is the process of collecting, treating and disposing. Collecting, treating, disposing of solid material so that is discarded because it is of no longer use. So this is solid waste management. So solid waste management, it is a process of collection, transportation, disposal of solid waste in a systemic, economic and hygienic manner. So classification of solid waste. So we have two types of classifications. So that is, first one is based on their source of origin, and based on their physical nature, based on their sources of origin and based on their physical nature. So based on their sources of origin, so we have residential waste, commercial waste, institutional waste, municipal waste, industrial waste, agriculture waste. So this is based on sources of origin: residential waste, commercial waste, institutional waste, industrial waste and also agriculture waste. Based on their physical nature, so this solid waste, this is classified as garbage, ashes, combustible and non-combustible waste, demolition and construction waste and hazardous waste. So we have based on physical nature, so garbage, ashes, combustible and non-combustible waste, demolition and construction waste and also hazardous waste. So this is a description about the the classification based on physical nature. That is, first one is garbage. So this is biodegradable food waste. Garbage is a biodegradable food waste. So this is a residual vegetable or animal waste resulting from the handling, preparation, cooking and eating of foods. So they are decomposed rapidly, especially in warm weather. So these biodegradable waste, so garbage, it is a biodegradable food waste. It is easily decomposed especially in warm weather. So the sources of this garbage is houses, hotels, dairies, meat stalls, etc. So for combustible and non-combustible solid waste, combustible solid waste as a paper, cardboard, plastics, textile, rubber, leather, wood, furniture and garden trimming. So these all are combustible and non-combustible solid waste. So non-combustible, so these are combustible waste. So combustible solid waste includes paper, cardboard, wood, so plastics, textile, rubber and textiles, rubber, leather, wood, furniture. So and garden trimmings. Non-combustible solid waste are glasses, crockery, tin cans, ferrous and non-ferrous metals. So ferrous and non-ferrous metals, these come under non-combustible solid waste. So the sources of combustible and non-combustible solid waste are households, offices, hotels and markets. So the sources of combustible and non-combustible solid waste are households, offices, hotels, markets. So here we are having garbage, and also second one is combustible and non-combustible waste. So third one is ashes. So these residues remaining after the uh, after the burning of wood, coal, coke and other combustible waste. So these are residues remaining after the burning of wood, coal, coke and other combustible wastes. So this source of this as are fireplaces and kitchens of houses, hotels and hostels, etc. Next is the fourth classification, that is demolition, and fourth solid waste is demolition and construction waste. So this is inert waste such as dirt, stones, concrete, bricks, pieces of plumbing and heating and electrical parts. These are come under demolition and construction waste. So these the sources of this solid waste is demolition and construction of buildings. Industrial waste, so these they are specific for a specific industry. So industrial waste, these are depending upon the type of industry, which industry is there. So their characteristics vary widely as inert, highly biodegradable, toxic, reactive, odorous and corrosive, hot, cold, colored, viscous, inflammable and dusty. So these industrial wastes are depending upon the specific in the specific industry. And also it is examples, so sources of industrial waste are different types of industries. Examples, thermal power plants. So this is the flowchart of engineered systems for solid waste management. So in this waste collection into dustbins, first process is waste collection into dustbins. Next, on-site handling, storage and processing. Second process is on-site handling and storage and processing. Third one is transportation. Fourth one is processing. Then we have to dispose the solid waste. So this is engineered systems for solid waste. Meant first collection of solid waste, after that storage and processing. So next transportation, after that different processing and also disposal. This is the solid waste management. So here methods for treatment of solid waste. So with different types of waste, different treatment methods are applied. So with the different types of waste, different treatment methods are applied. So these treatment process has been listed below. So here these methods are used for the treatment of solid waste. So here open dumps, landfills, anaerobic digestion, composting, vermicomposting, encapsulation and incineration. So these are the treatment processes were different for different types of waste, different treatment methods. So these are different treatment methods for the treatment of different solid waste. So here open dumps, landfills, anaerobic digestion, composting, vermicomposting, encapsulation and also incineration. So here open dumps. This is a description about open dumps. Open dumps, these refer to uncovered areas that are used to dump solid waste of all kinds. So open dumps, these refer to uncovered areas that are used to dump solid waste of all kinds. So the waste is untreated and not segregated. So this waste is not treated. This is untreated and also not segregated. It is the breeding ground for flies, rats, and other insects that spread the diseases. So this is the breeding ground for insects which are spreading the disease. Examples: flies, rats, and other insects. So when the rainwater runoff from these contaminates these water contaminates nearby land and water, so thereby spreading diseases. So in some countries, open dumps are being phased out. So here, so in some countries, open dumps are being phased out. So second treatment is landfills. A landfill so may also refer to the ground that has been filled in with, so this has been filled in with soil or rocks instead of waste materials, so that it can be used for a specific purpose such as for building houses. So landfill, also known as dump or a tip, it is a site for disposal of waste materials by burial. So older, the poorly designed or poorly managed landfills can create a number of adverse environmental effects, such as wind-blown litter, attraction of vermin, and generation of liquid leachate. So here landfill, it is also this it is in this we have to we are burying the waste materials. So here this is a landfill, it is a known as dump or a tip. It is a site for disposal of waste materials by burial. So but it is a very good process, but it is the poorly generated or poorly managed landfills can create number of adverse effects on the environment. So sanitary landfills, so these sanitary landfills, so these are designed to greatly reduce or eliminate the risks of waste disposal may pose to the public health and environment quality. So here these sanitary landfills are good landfills, so which are used for the disposal of solid waste materials. So these sanitary landfills, these are designed to greatly reduce or eliminate the risks of waste disposal may pose to public health and environmental quality. So next process is composting. Composting is the biological decomposition of organic waste under controlled aerobic condition. Composting, it is a biological decomposition of organic waste. Biological decomposition of organic waste under controlled aerobic conditions. So here industries as paper, agriculture and food processing give out wastes which are almost 100% organic. The industries of paper, agriculture and food industries, these give out 100% organic waste, organic solid waste. So this organic matter can be composted to yield good manure. So this organic matter, this can be composted to yield good manure. So compost is the end product obtained after subjecting the organic fraction of solid waste to aerobic or anaerobic decomposition to yield humus like solid, carbon dioxide, water, vapor and energy. So here by composting, so this is the end product. Compost is the end product. So the end product which is obtained by the composting process is known as compost. So it is the end product obtained after subjecting the organic fraction of solid waste to aerobic or anaerobic decomposition to yield humus like solid, carbon dioxide, water, water vapor and energy. So we will get carbon dioxide, water and energy, and also solid material, humus like solid material, that is also called as compost. So different stages of composting. So composting in this segregation of solid waste. So composting in this different stage of composting is there. So segregation of solid waste, processing of compostable matter, preparation of compost, digestion, curing and screening. So these are the different stages of composting. In this organic matter, this is treated with oxygen that in presence of aerobic bacteria. in presence of aerobic bacteria. So this will give carbon dioxide, water and also ammonia and also energy other end products. So it is giving CO2, water vapor and energy, water vapor and energy. So when the in this reaction is in this composting, organic matter is treated with oxygen in presence of bacteria, that is aerobic bacteria. So then it will give CO2, water and ammonia, energy and other end products. So the organic matter, this is treated with anaerobic bacteria, so this will give methane and CO2, H2O, ammonia and H2S as the main product and plus energy and other end products. So when organic matter it is treated with oxygen in aerobic in presence of aerobic bacteria, so we will get carbon dioxide, water vapor and ammonia, energy. So in case of organic matter, when it is treated with anaerobic bacteria, so it will give carbon dioxide, water, ammonia. So as well as with these products we will get methane and also H2S plus energy. So what is the mechanism of composting? So composting, it is a very complex process involving the participation of several microorganisms like bacteria, actinomycetes, myositis and fungi. So in this process we will the bacteria, so in this process, composting process, it is a complex process. It will involves the participation of several microorganisms like bacteria and fungi. So the bacteria bring out the decomposition of macromolecules, namely proteins and lipids. So generally paper and agriculture waste, food industry waste, this will have carbohydrates, means so these are having proteins and lipids. So these are macromolecules, the decomposition of macromolecules. The bacteria, which is bacteria, this is bring out the decomposition of macromolecules such as proteins and lipids. So besides generating heat energy, fungi and actinomycetes degrade cellulose and other complex organic compounds. So bacteria, so this is decomposing that proteins and lipids, and also so besides the generating heat energy, the fungi and actinomycetes, so this degrade cellulose and other complex organic molecules. So this composting may be divided into three stages. So this with reference to changes in the temperature. So this composting, it is divided into three stages with reference to changes in temperature. With changes in temperature. So first one is mesophilic stage, thermophilic stage and cooling stage. Mesophilic stage, thermophilic stage and cooling stage, depending on upon the changes in reference to the changes in temperature. So next, anaerobic digestion. So anaerobic digestion, it is a regulated version of natural events of landfill, in that it results in the controlled release of methane rich biogas, which offers a potential of for very real form of energy from the waste. So anaerobic digestion, it is a regulated version of natural events of landfill, in that it results in the controlled release of methane rich biogas, which offers the potential for a very real form of energy from waste. So we will get methane, so by the anaerobic digestion of landfills. So it is carried out in large fermented tanks. So this anaerobic digestion, it is carried out in large fermented tanks. In these tanks, solid waste, it is taken in absence of oxygen, and the anaerobic bacteria convert large organic molecules mainly into methane, carbon dioxide. So mainly an aerobic, by the anaerobic digestion, we will get methane and carbon dioxide. Methane and carbon dioxide. So in this, so this anaerobic digestion, it is carried out in large fermented tanks. In these tanks, the solid waste is taken in absence of oxygen, and aerobic in absence of oxygen. So we will convert these micromolecules into methane and carbon dioxide. So unlike composting, anaerobic addition occurs at one of the three distinct temperatures ranges, namely. So this, unlike the composting, anaerobic digestion occurs at one of three distinct temperatures. So that is cryophilic below 20 degrees centigrade, mesophilic 20 to 45 degrees centigrade, thermophilic above 45, that is 45 degrees centigrade. So in the Arabic and anaerobic digestion, so we are the in microorganisms are playing very crucial role. So here these are the some of the microorganisms which are involved in anaerobic digestion. So there are four main group of bacteria are involved in aerobic digestion. So as shown below, so with some typical examples of each. So first one is hydrolytic fermentative bacteria. Hydrolytic fermentative bacteria. So example Clostridium and Peptococcus. So here estrogenic bacteria, Centrophobacter and Centrophomonas. Estrogenic bacteria, so this is Methanosarcina and Methanothrix. And methanogenic bacteria, so example of methanogenic bacteria, Methanobacterium and Methanobrevi bacterium. So here, so we four types of bacteria are involved in the anaerobic digestion. So first one is hydrolytic fermentative bacteria, acidogenic bacteria, methanogenic bacteria. So this is the digestion process in anaerobic digestion process. In this involves four types of process steps that are hydrolysis, acetogenesis and methanogenesis. Hydrolysis, acetogenesis and methanogenesis. So here first the complex organic matter. So examples of complex organic matter, it is fat, carbohydrate, protein, lipids. So these are taken in a large fermented tanks. In this first step is hydrolysis. In this it is takes place in presence of hydrolytic bacteria. So this complex organic matter, it is converted into monomeric unit in presence of hydrolytic bacteria. So examples glucose, fatty acid, glycerol, etc. So in second step is acidogenesis process. This takes place in presence of fermentative acidogenic bacteria. So in these monomeric units, the glucose, fatty acid, glycerol, these are converted into organic acids. Examples acetic acid, butyric acid, propionic acid. So and also alcohol and ketone. In acidogenesis, these monomeric units are converted into organic acids. In acetogenesis process, third step, this is takes place in presence of acetogenic bacteria. So in this, these organic acids and alcohol ketones, these are converted into acetates and carbon dioxide, water. Acetates, carbon dioxide and water. So last step is methanogenesis. In methanogenesis, this is the process takes place in presence of methanogenic bacteria. So in this last step, we will get methane, carbon dioxide and water. Methane, carbon dioxide and water. This is the brief explanation about anaerobic digestion. So in this we have four steps. First one is hydrolysis. So in this macromolecules are converted into monomeric units. So in the second step acidogenesis, in this monomeric units are converted into organic acids. For third step is esteogenesis. Esteogenesis, organic acids are converted into organic acids, acetates, and these acetates finally this will give methane and CO2 and water by the methanogenesis process. So for next process is vermicomposting. Vermicomposting, it is a simple biotechnical process of composting in which certain species of earthworms are used. In this vermicomposting, so we will use earthworms. So to enhance the process of waste conversion and produce a better end product. So here vermicomposting differs from composting in several ways. So utilizing microorganisms, so here earthworms that are active at 10 to 32 degrees centigrade. So here vermicomposting, so we can use microorganisms also in this. The process, it is faster than composting. So because the material passes through earthworm cut, and it is but not a fully understood transformation takes place, so whereby the resulting earthworm castings, so these are rich in microbial activity and also plant growth regulators. So here vermicomposting, it is a simple biotechnological process of composting in which certain species of earthworm are used to enhance the process of waste conversion and produce a better end product. In this we are using earthworms. So by using this we can convert the waste products into the useful product, better end product. So the manure which is resulting from earthworm casting, these are rich in microbial activity and also plant growth regulators. So this is the process of vermi composting. Here we are having 12 stages. So first one is collection. So like this we are having different stages. So finally we will get the manure. So that is composted uh, solid waste. So next process is encapsulation. So this is solid particulate waste material. So the solid particulate, dangerous solid particle waste, that is toxic solid particulate waste material, it is coated with a thermosetting resin. It is coated with a thermosetting resin. So which is compressed and cured to form rigid coat. So here the solid particulate waste material, it is coated with a thermosetting resin and which is compressed and cured to form rigid core. So this rigid core, this is coated with a flexible thermoplastic resin to provide a sealed encapsulated waste, and this can agglomerate, this can withstand the compressive loads. So this is the encapsulation process. So by this encapsulation, so the toxic materials, so these cannot expose to the environment. So here encapsulation methods, these are two types: macro encapsulation and micro encapsulation. So next one is incineration process. In this incineration process, it is the most common thermal treatment process. Incineration process, it is a thermal treatment process. It is burning of waste. In this process, we burning of waste is takes place. It is at temperature of 1000 degree centigrade plus or minus 100 degree centigrade, means 1000 to 1100 degree centigrade, in the presence of oxygen, so as to eliminate all odors and to ensure good combustion. So here, so this is a thermal treatment process. It is takes place above 1000 degree centigrade. So in this solid waste material is burned at the temperature 1000 degree centigrade in the presence of oxygen, so to eliminate all odors of the solid waste and to ensure the good combustion of solid material. So after incineration, the wastes are converted into carbon dioxide, water vapor and ash. So here after incineration, so these waste products are converted into again CO2, water vapor and ash. So these, it converts hazardic, this process it converting hazardous organic substances into less hazardous components. So incineration means thermal treatment process. So next topic is management of solid waste. So the fundamental objective of waste processing, waste management, it is to reduce the amount of waste through recycling and disposal of waste in a way not to impair environmental conservation. So the management of solid managed waste, it is done according to its nature. So first is management of medical solid waste, management of non-biodegradable solid waste, management of hazardous waste, management of non-hazardous and biodegradable solid waste, management of electronic, that e-waste. So first one is management of how to manage the medical solid waste. So hospital waste, it is generated, that is medical waste or hospital waste, solid waste, it is generated during the diagnosis, treatment, immunization of human beings or animals, so or in research activities in these fields, or in the production or testing of biological. So this is produced the hospital waste or medical waste. It is generated during the diagnosis, treatment, immunization of human beings or animals, or in research activities, also in the fields, in the production of medical solids, sorry, medical equipment, and testing of biological. So these are medical waste, solid waste. Medical solid waste, it includes both non-hazardous and as well as hazardous waste constituents. So first one is the non-hazardous waste and hazardous waste. So we can treat these non-hazardous and hazardous waste by using incineration process and sanitary landfill. We have already discussed about what is incineration and sanitary landfill. So by using these two processes, we can manage the medical solid waste which are produced from the hospitals and research activities and also production industries. So next one is management of non-degradable solid waste. So here examples of non-biodegradable solid waste are ferrous, non-ferrous metals. So here examples of non-biodegradable waste are ferrous and non-ferrous metals. Examples iron, steel and also aluminum, etc. So these are ferrous and non-ferrous metals, and also glass, plastics, textiles. These are non-biodegradable solid waste. Ferrous and non-ferrous metals, glass, plastics and textiles. These are non-biodegradable solid waste. How to treat these non-biodegradable solid waste? So by using recycling process, sanitary landfill and also incineration process. By these three processes, we can manage the non-biodegradable solid waste. So next is management of hazardous waste. Following a process applied in non-hazardous waste treatment. Management of hazardous waste. So here, so some processes are there: physical separation, gravity separation, dissolved air flotation, solvent extraction, sorption on activated carbon. So these are the process applied in hazard waste treatment. So another treatment options are thermal treatment, that is incineration, and biological treatment. By using these two treatments, we can manage the hazardous waste. So here thermal treatment, that is incineration, and biological treatment. Next, management of non-hazardous and biodegradable solid waste. So here non-hazardous solid waste, it is a total waste including municipal waste, industrial waste, agriculture waste, sewage, sludge. So here non-hazardous. So non-hazardous solid waste, it is includes total waste including municipal waste, industrial waste, agriculture waste, also sewage, sludge. So here the following methods are used for the management of non-hazardous and biodegradable solid waste. So these are open dumps, landfills, anaerobic digestion, composting and vermicomposting. So these are the processes which are used for the management of non-hazardous and biodegradable solid waste from the municipal waste. So this is a conclusion. In this solid waste management, it is a process of removal of solid waste in such a manner that it does not cause any problem to the environment and the living organisms as well. So it is done through different methods as per the category of the solid waste. So here in this session we have discussed about different different methods which are used for the management of solid waste. So I'm concluding this session. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.